Hello to all my friends! Continuing with the instructional videos about the LS100 inverter, in the previous video, we talked about the user sequence feature, or the built-in PLC, of the LS100 inverter, and we mentioned that the LS100 inverter has a user sequence feature, which is basically an internal PLC, and the only way to activate and program the built-in PLC of the inverter is through the DriveView software from LS. We mentioned that in the DriveView software from LS, which is designed for LS inverters, we can use various functions for our programming. We said there are 18 steps, 29 functions, and 30 variables. In order to use constant values in our programming, alright, here we have the DriveView software open. We're going to create a new project quickly. We go to the File menu and select New Project. Our inverter is the S100, so we select the S100 for our project. We name it User Sequence and confirm it. Alright, now we've created a new project. To connect to our inverter, we click on the Settings option. We select the settings for our protocol, which is Modbus RTU RS485. We set our station number to 1, and we've connected to the inverter through COM port 3. We set the baud rate to 9600 and 8N1, confirm it, and then click on Connect. As you can see, I'm now online and have connected to the LSS100 inverter through the DriveView software. Now, to bring up the user sequence programming environment in the DriveView software, in the project window, select User Sequence. Now you can see the functions that we're going to use to do our programming. Here they've been created for us, and you can see we have access to the functions. As we mentioned, there are 129 function blocks in the inverter. To use any of these functions, all you have to do is click on them. A new page will open for us, and if we click this option here, you'll see it. It shows us all the functions that we can use in our programming line by line. Now, we are going to write a specialized control program within the DriveView software interface so that if my specific command frequency happens to rise above the 5 Hz threshold, my power inverter will automatically start running. And conversely, if my command frequency drops back down below that 5 Hz level, then my inverter will be programmed to come to a complete stop. So when we say my command frequency is greater than 5 Hz, we need to use a greater than function. So for the comparator functions, we said we want to use a compare function here. We use a greater than function, or the same greater than option, by selecting the compare GT, or greater than, and then clicking right. Now, since my user sequence is active here, first I reset it. So, as we said, first we need to enable the user sequence feature in this Inverter 100. To do this, we said we'd go into the AP group. In parameter number 2, we set this option to yes, or 1. Here, we set it to yes and write it. Now we've enabled the user sequence feature, and we go back. In that same user sequence section, we said that when you select this function, or the greater than comparator, you press right. Now this function has been set as the greater than comparator. I press monitoring and then exit from Mytronic again. You can see that the comp_GT function appears here for me. Okay, this function has 3 inputs, input A, input B, and input C. So how should I set these up? I go to the USF group. Here, the function we've selected, you see that GT stands for greater than. To set up input A to assign its value, you can see that in the USF group, parameter number 2 is for input A, number 3 is for B, and number 4 is for C. In the greater than function, we said that if A is greater than B, whatever value we have in C will be sent to the output. So we said that we want to set the command frequency from a fixed value. Now, we said if it becomes greater than a fixed value of 5, my inverter is supposed to start. So my input A is related to my command frequency. I click on it. It opens a page for me. I go into the groups, and in the group, I assign the DRV command frequency to input A. Now, my input A is the same as DRV 2-0, or in other words, my command frequency for B. I need to enter a fixed number. Well, for a fixed number, we said we have to use constants, and the constants are in the USS group. When we select it, we see that we have 29 different constants that we can assign values to. Okay, I'm going to use constant 1. To assign a fixed value to constant 1, I tap on the setting option. Here, its value is 0. I enter the value 5, hit save, and write it. Okay, now my B has the fixed value of 5. All right. I said that if my A is greater than B, it will transfer C to the output. Okay, so in these L versors, the address for start and stop is address 6 hex. If the value at this address is 1, this versor will stop. Music. If it's 2, this video will start in the forward direction, and if it's 4, this video will start in the reverse direction. Now, for example, in this video, we want it to start in the forward direction. That's why we need to set address 6 to the value 2. So, since A is greater than B, it sends C to the output. We select another parameter, input C, set its value to 2, save it, and then click on the write option. All right, so where do we select the output of this function? Let's see. USS link group, user out 1. This is related to the output of function 1. We said we want to set the output of function 1 to the value 2. We write the value 6 to the inverter's hex address here and click on write. Alright, now for function 1, I click on the monitoring option. Then I exit monitoring again. You can see that its first input is DRV0, which is my command frequency. The second input is void parameter 1, which has a value of 5. My third input is also void parameter 2, which has a value of 2. So if my A is greater than B, the output will be set to the value 2, which is my output. The address is 6 hex. Alright, so this was for starting up this inverter. Now, if I want my inverter to stop when its frequency drops below 5, I need to use a greater than function for that. Again, for the second one, I select the greater than function and click on write. Okay, this function is done too. Now I click on the greater than function for monitoring. If I check again, you can see that the second function, compare GT or greater than, has been selected. For the second one as well, you can see that my user function 2 is set to GT. We said that we want our inverter to stop if the frequency value drops below 5. So we need to assign the constant value 1 to the output of this function, which is the inverter's hex address. We mentioned that if we send the value 1 to the inverter's hex address, the inverter will stop. All right, let's go. First, I'm using the constant value 5, the same constant 5 I used in video 2. So I select video 2, and 5 will be my second input. I assign the drive mode or the frequency set point to it for C as well. I am going to use the third parameter, and then I'll assign it a value of exactly 1. Now I go to the user sequence section. Now it's set up so that if the parameter is... Alright, here, parameter 1 should be selected. I had put 2. If my parameter 1, which is 5, as long as it's higher than my frequency command, the value of my 600 hex address should be 1, and this inverter will stay stopped until my frequency command passes 5 Hz. It will execute this function and assign the value 2 to the 600 hex address. Alright, up to this point we've written the program. Now, let's go back into USS and assign the output address for function 2 to the 600 hex address as well. Okay, our programming is now complete, so if we want to, have the user sequence automatically start and stop the inverter. It's necessary for my command source, or my start/stop, to be set through the user sequence option. We set it to user sequence, and we also set the FRQ to the same keypad. We'll assign its value from the keypad. But our start/stop will be controlled through the user sequence, because this inverter is supposed to be started and stopped automatically through its internal PLC. We set it to user sequence and click write. Okay, now everything is ready, and I've written the program. Now my programming is complete, and I need to write the program I've created into this inverter. I click on the parameter write option, select all parameters and all groups, and then click OK. First, USS. Needs to be in stop mode so the program can be written. I click write again. I select all the groups and click OK, then wait for all the parameters to be written internally. Okay, now I've written the entire program I created into the inverter. I'm going back again. Now in the DRV command source group, I set it to user sequence and click write. Then I go to the USS group and run the user sequence. Okay, there's another change we need to make in our program, is that I bring it up from the monitoring section because the value of my command, which is shown here, the inverter considers this as 300, meaning it ignores the decimal point. 300 means 300. So in the program, when I want to set the value of the speed parameter to 5, I actually need to set it to 500, meaning 5.00. Keep that in mind. For the next part, again, when I want to set it to 5, do you see that I wrote 500 here? Okay, now I've loaded the program into the inverter. I'm going to S. I'm gonna run the user sequence feature on my inverter, close it, and now I'll hit monitoring. Let's go to the inverter. Okay, now you can see that the inverter is in stop mode. Why? Because we said that if our frequency command value is less than 5 Hz, the inverter should be in stop mode. So here, for example, we'll set the frequency command value 10 Hz. 10 Hz is greater than 5 Hz, so the inverter should actually start and start up our electromotor. I'll hit write. You'll see, as soon as I press write, my inverter starts up at a frequency of 10 Hz in the forward direction. Now, again, I'll lower my frequency to less than 5. For example, 4 Hz and hit write. When I do that, my inverter's frequency drops, and you can see it goes into stop mode. So we learned how to add functions in the DriveView software, and how to define each of the inputs related to those functions. If we want to define constant values, we need to assign them to each of these inputs. And also, if we want to select the output of any function, which parameter group should we go into? In the next videos, with more examples and more exercises, we'll get more familiar with this user sequence feature of the inverter.